Okay, welcome back. We've got our anatomy of our linear relationship now, and y and x, we're free to let those just kind of hang. The values we really need is m and b. So the question becomes, how do I get it? Right? How do I get m and b? How do I get my slope? How do I get my y-intercept? And I'll go ahead and tell you, don't do it by hand. Right? I'm not even going to bother putting the formulas up for doing these regressions because it's just, you're not going to do it. I'm not going to ask you to do it. No one's going to ask you to do it, I hope, unless you get some really sadistic professors in the future, but I just don't. Really, the way you find m and b, the way you find your slope, the way you find your y-intercept is you use technology. Same as we've been using technology to find all the other nasty major findings in this course. So in Excel, the go-to, is the linest, the linear estimator command. And you will highlight your first data set, comma, second data set, and that will give you two values. It'll spit out for you two values. It'll give you slope and y-intercept. And there you go. That's how you do it. You can also pull up Excel and pull up your scatter plot specifically and add a trend line. And if we have time here, we'll do that as well. If you're using Desmos, you can do y tilde mx plus b, and it will spit out not just your R value, it will also give you M, it will also give you B, and Y1 and X1, you just have to type in all the values you've got for your two lists, and there's M and B for you. So there's a variety of ways to get it. So if you're doing trend lines, if you're doing Excel, and you don't want to do the linest command, the way you do it is you just make a trend line, you say you want it to be a linear trend line, and have it spit out the equation for you. And look, there's y equals mx plus b. Perfect. That's all you have to do. You can also use linest, you can also use Desmos. There's a variety of ways to do that. In class, we'll practice doing it a couple different ways. But once you have m and b, you are pretty much done, right? Once you have m and b, you have your linear relationship. You can start making predictions of what one variable will be given another. So yeah, so usually you get to play with x and determine y, that's the dependency, but again, you could do it the other way around, right? Relationships don't care. This is not a cause and effect situation. And please don't ever pretend that it is. But whatever you're doing, be absolutely sure that the values you're playing with fall into your existing ranges. Because if you are playing with a linear relationship and you're going way out of town, way beyond the range of what you have to work with, you can't reliably say that it's going to stay linear. A lot of relationships out there have a linear zone where it is a nice linear relationship, but once you get past that, all bets are off. So just stay within your data ranges. I got an example here for us real quick, right? Suppose we did all this, suppose we did linest, or suppose we did a trend line, or suppose we played in Desmos, and we came up with this linear relationship between two variables. So y is 2.047x plus 15.91. That's our trend line equation. That's our linest equation. That's what we've got to work with, which means that for any x value I can put in, well, preferably something between 10 and 20 anyway, I can predict what y becomes. And that really is just a plug and chug kind of situation. That really is just a substitute the value for x and see what y comes out to be. This is a predictor. It is not the gospel truth, but given that they are linearly correlated, given that we have quantified the relationship to be mx plus b, then we can start predicting what one value becomes given the other, right? We might not have control over that. It might not be a cause and effect relationship, but if we have one, we can predict the other. And it's just pure arithmetic from there. Not so bad. Anyway, again, we'll do some practice with that in class, but it's not that much. Once you have M and B, it's just arithmetic from there. And that's great news. That's it. That's linear regression in a nutshell. Make technology do the regression for you. Don't do it unless you have correlation established. But once you have correlation established, once you have this relationship, you can make predictions within your data range. Lingering question, what if they're not correlated? Well, don't do linear regression. Instead, just take everything to average out. It's the best guess you got. Or you can try for other types of correlation. And maybe I'll make a video series about some other types of correlation, but that's it. That's regression. You done it. Bye.